So, in this video, we're gonna discuss about semantic matching. So, we're gonna apply semantic matching for image and text. Here, we're gonna use AutoGluon's multimodal. So, to begin with, we're gonna install the required libraries. So, basically, AutoGluon provides a seamless interface for multimodal tasks, and Torch Audio ensures compatibility with certain backbones. We also download the dataset for this tutorial, which comes from the Flickr 30K dataset containing paid images and captions. So basically, after unzipping, we load the training, validation, and test dataset into pandas data frame. Each row in this data frame corresponds to an image caption pair. To use the image paths correctly, we expand the relative paths into absolute paths. This ensures smooth access to image files during training and evaluation. So each image corresponds to 5 unique captions. Here's how we can visualize unique image caption pair. So understanding the structure of your data is essential for interpreting model results later. So now we initialized a pre-trained multimodal predictor for image text similarity. Basically, this model is based on CLIP, therefore OpenAI CLIP with base patch 32. It's a state-of-art model for understanding relationships between images and text. We also perform a zero-shot evaluation to see how well-trained model performs without any fine-tuning. So also the record scores indicate how many correct matches the model retrieves within the top K results. So to improve the performance, we fine-tune the model on our dataset. Basically, this adapts the pre-trained weights to our specific data. Fine-tuning leverages the relationships in our dataset, yielding better results for retrieval tasks. So we reevaluate the model after fine-tuning, measuring both text-to-image and image-to-text recall. So also notice the significant improvement in recall scores, highlighting the benefits of fine-tuning. One of the powerful applications of this model is semantic search. We can retrieve semantically similar images for given text query. We can also perform the reverse operation, retrieve similar captions for an image query. This is an incredibly useful for tasks like content-based image retrieval. Finally, the predictor can determine whether an image caption pair matches the output probabilities. So this probabilities helps interrupt the confidence of the model's predictions. So we can also extract embeddings for images and captions, which are vector representations that encode semantic information. So embeddings are key to advanced applications like clustering or visualization. So this is all about the semantic search which you can implement. That's all. Thank you. And then moving on to image text zero shot. So in this we are going to use AutoGluon multimodal. So we start downloading the AutoGluon's download utility. So these URLs represent a variety of scenarios like managing right-wing horse or monkey playing drums. So we also prepare a list of descriptive text captions for semantic matching. To analyze image text relationships, we need to extract embeddings, numerical representations of images and text. We then initialize the predictor for image text similarity. Then we extract embeddings for both images and text. So these embeddings allow the model to understand semantic similarities between images and text. So after retrieving images based on text query, for example, we search for the text, there is a carriage in the image. So the model retrieves the most semantically similar images. Then we visualize the top result. So basically this process demonstrates how semantic search can identify matching images based on textual descriptions. Similarly, we can reverse the process by retrieving text captions for given image. For example, we take an image of man, people riding a horse. We then retrieve text descriptions. So the model identifies top matching text, man is riding a horse. So beyond semantic search, we can predict whether a specific image text pair matches. For this, we reinitialize the predictor with query and response arguments. Given an image text pair, the model predicts whether they match. So basically, the output indicates whether the image and the text are a match. So to get more detailed insights, we can calculate the matching probabilities. So this approach is useful when you want to apply custom thresholds to decide matches. So the extracted embeddings allows for advanced applications like semantic search and so on. That's all about this code. Thank you. And then next we're going to discuss about image to image matching. So using autoglue multimodal, we're going to explore image to image matching. So first we install the required packages to enable autogluons multimodal capabilities. So basically this library simplifies image-based tasks with powerful pre-trained models and an easy-to-use API. We download the Stanford online first dataset, which is great for image similarity tasks. So basically the dataset contains pairs of images and labels indicating whether the images are a match or not. Then we load the data into pandas data. To ensure that images load correctly, we expand the relative paths into absolute paths. So this pre-processing step ensures that both training and test images are easily accessible. Then let's visualize the dataset. So displaying an image pairs. So here is an example of two images that do not match. Understanding your data is visually crucial before diving into the modeling. So these are the sample images, and then diving into a multimodal predictor for the image similarity task. So here, query and response define the column for two images. Label specifies the column containing match labels. And also match label indicates the label for matching pairs. So now let's train our model. So AutoGluon simplifies the training process by automatically selecting the best model and configurations. So after training, we evaluate the model on test set to check its performance. The model uses the AUC, the area under the curve metric, which measures its ability to distinguish between matching and non-matching pairs. Let's predict whether the first three image pairs in the test set are matches. So the predictions are binary using a default probability threshold of 0.5. So if you want to find a control, you can get the matching probabilities for each pair. So basically this approach is useful for applying custom thresholds or understanding the model's confidence in its predictions. Another powerful feature is embedding extraction. So where the model generates vector representation of each image. So these embeddings are useful for downstream tasks like clustering, visualization, or custom similarity metrics. So that's all about image-to-image matching with AutoGluon. Thank you. Next, moving on to text semantic search. So we'll explore text semantic search using AutoGluon. We'll walk through data preparation, BM25 baseline ranking, and also embedding based semantic search, and hybrid methods combining traditional and deep learning techniques. So we start by loading the IR dataset using the IR datasets library. So this dataset contains queries, documents, relevant labels, and so on. So after installing and importing, we load and prepare the data. The doc underscore data contains document IDs and the corresponding text, while query underscore data stores query IDs and their queries. And the label underscore data maps queries to documents with relevant scores. So let's clean the dataset by dropping unnecessary columns like URL and concatenating the text fields in the document data. This ensures our data is streamlined and ready for semantic search. So to evaluate a baseline ranking, we use the BM25 algorithm, a popular method for information retrieval. We token analyze the documents and queries, and then calculate BM25 scores. So we then rank documents for each query and we compute evaluation metrics like NDCG. So BM25 provides a good starting point for evaluating a retrieval pipeline. Then we move on to deep learning based semantic searching using autoglue-on multimodal. First, we initialize a predictor with a pre-trained transformer model. Then we evaluate the model's performance by computing NDGC scores on the labeled data. So this method leverages embeddings to rank documents based on semantic similarity. So semantic search uses embedding for text-to-text retrieval. We extract embedding for queries and documents. Using these embeddings, we can perform semantic search. So semantic search retrieves the most relevant documents for each query. So for better performance, we combine B25 scores with embedding-based similarity. So this hybrid approach uses a weighted combination of BM25 and cosine similarity. We evaluate the method using NDGC metrics. So this hybrid approach combines the strengths of both methods for improved retrieval accuracy. So that's all about semantic text search. Thank you. And next, moving on to text to text semantic matching. So we're gonna do text to text semantic matching using autoglue-on multimodal. So this is ideal for tasks like natural language inference, semantic similarity, or duplicate detection. So here we're gonna use the SNLI, the Stanford Natural Language Inference dataset, which contains pair of sentences with labels indicating their relationships, such as entitlement, contradiction, or neutral. Let's start by installing the necessary libraries and then we load the dataset. So basically, this dataset includes columns like premise, hypothesis, and label, where premise indicates the first sentence, hypothesis indicates the second sentence, and label indicates whether the sentences are semantically similar. We initialize an autoglue-on multimodal predictor for text similarity tasks. So this configuration automatically handles feature engineering, model selection, and training. Then we train the model on the SNLI training dataset, setting a time limit, and then autoglue simplifies the training by selecting the best model and hyperparameters for the task. This step is crucial for fine-tuning and model on your specific dataset. So once trained, we evaluate the model on the SNLI test dataset using the area under the curve metric. So this evaluation provides insights into the model's ability to differentiate between matching and non-matching sentence pairs. So let's test the model on the new data. We create a sample example data set. Then we predict whether the sentences match. And then we calculate the probability of the match. This allows us to interpret the model's confidence and its predictions. So basically, autoglue also enables embedding extraction, which is useful for downstream tasks like clustering or semantic search. So these embeddings encode semantic information and can be visualized or analyzed further. So the extracted embeddings and predictions reveal how well the model captures the relationships between the sentences. For instance, high similarity scores indicate entitlement or semantic agreement. Entitlement or semantic agreement. So low scores suggest contradiction or unrelated meaning. So these insights are crucial for tasks like paraphrase, detection, document similarity, and more. That's all about this video. Thank you.